Hey chemistry class, since we cannot meet in person today, I want to go through a few problems. First off, what we're doing in this video is Module 11, Extra Practice Problem number 3. Now normally I would write down my given and my find information as I read through the problem. Since I'm going electronic here, I'm going to color code it. I've copied the balanced equation up top, and all the pertinent information I'm going to write with it. So I see that I've got a 1.51 molarity solution of HCN, so I'm writing 1.51 molarity under HCN. And I've got 50.0 grams potassium cyanide, so I'm writing that under the KCN. And then I want to remember what I'm looking to find. I'm looking to find milliliters of HCN. So I want to remember that's what my goal is. And if that's where I'm going to finish the problem, I probably need to start the problem with the other information, which is the KCN. Now I have mass of KCN, and I want to take that into moles. Before we get started, we need to think about how do we use this balanced equation. Remember, it doesn't mean that this much mass equals this much mass or this much volume equals this much volume. These equations refer to moles of a substance. In this case, everything in the equation has a coefficient of 1. It's not there, that means it's a 1. So everything's a 1-to-1 ratio. So what I want to do is get my KCN in moles, and once I figure out how many moles of KCN I have, that will tell me how many moles of HCN I have. And once I get there, I can figure out with moles and molarity what my milliliters or my volume is. So if we have 50 grams of KCN, how do we convert grams to moles? And that's where we use AMUs, those atomic mass units, and we use our periodic table of elements to figure that out. So just go to your periodic table of elements, bring in the information individually for K, potassium, C, carbon, and N, nitrogen, and you'll get that KCN molecule has 65.1 AMUs. What does that mean? If you have forgotten, that means that 65.1 grams is the mass of 1 mole of KCN. Okay, so now we have 50 grams of KCN. We have an equivalence about moles to grams. How do we switch that over to moles like we've been doing all year long? Just set up a fraction where you can multiply that 50 grams by a fraction that's equal to 1. That fraction will have a denominator in the bottom that'll let you cancel out what you want to get rid of. And the numerator, it'll let you bring in the kind of units you want to keep. So for us, we've got 50.0 grams, and we want to have 1 mole, so we can have moles as our units, and at the bottom we're going to have 65.1 grams, so we can cancel out those grams, and that gives us 0.768 moles. However, please don't write your equation like I did here, because you've got 2 different compounds you're dealing with. You're dealing with KCN, HCN, and you need to make sure that you keep yourself straight on what's what. So when you do this, you need to edit it so it says 50 grams of KCN. And then when you do your conversion, say 1 mole of KCN is equal to 65 grams of KCN. And so your final answer is that you have 0.768 moles of KCN. Please make sure you do that so that you know what compound you're dealing with at any time. So now we know that we have 0.768 moles of KCN. How do we figure out how many moles of HCN we have? Well, it might be kind of obvious here. It's a 1-to-1 ratio, but it's always good to practice doing this mathematically so when you have a more complicated one, you know what to do. So again, we're going to convert. When you convert, you bring in a fraction. The fraction's equal to 1. The bottom, the denominator, lets you cancel out what you don't want to keep, and the numerator brings in what you do want to keep. So we're going to take our 0.768 moles of KCN, and our ratio is just 1-to-1, so it's 1 mole of HCN is equal to 1 mole of, and I went a little dyslexic, hold on, KCN. And this one, easy math, like I said, you probably could have skipped this step, but you need to know how to do it for the harder problems. So now we know that we have 0.768 moles of HCN. So let's update where we are in our problem. We did just already, we solved that we had 0.768 moles of the KCN. We have 0.768 moles of the HCN as well. So now we actually have everything we need to know to finish up by using our molarity equation. We have molarity of HCN and we have moles of HCN, so we can easily solve for liters. So we are going to steal this equation if we can. All right, we know molarity is number of moles over number of liters. We know our molarity is 1.51, and we know our number of moles is 0.768 moles of HCN, and we want to get our liters of HCN. And if we solve for that, what we're going to get as our final answer in liters is we're going to get 0.509 liters. For our final answer, we do need to convert that into milliliters. And in case you have not heard me say it enough yet, how do we do a conversion? We multiply what we're starting with by a fraction that is equal to 1. That lets us cancel out the units we want to get rid of and bring in the units we want to keep. And so we are going to bring in milliliters and get rid of liters. And our conversion for that is, how do we make that equal to 1? Well, how many milliliters is equal to how many liters? That's 1,000 milliliters is equal to 1 liter. We do that and we get our final answer, which is 509 milliliters.